So in this video, I'm going to show you how to summarize one quantitative variable graphically or visually. So let's start with this example. The following list consists of pulse rates that are measured in beats per minute. They're measured from a sample of statistics students. Okay, and so here you see the list of pulses. Now, what can you tell me about the pulses just by looking at this list? Well, the truth is you can't really tell me very much. When the data are organized as a list like this, it's just not very helpful. The human eye can't really make much sense just looking quickly at a list like this. For example, I can't tell you what is the range of the values, what is the most frequently occurring value or the seeming center. I can't tell you if there are extreme values or what is the shape of the data. And can you imagine if there were 1,000 pulses, it would be even worse, or even 10,000. So I just can't make much sense of the data when it's in the format of a list like this. So our first goal, as I promised before, was I'm going to show you how to summarize the data. So it's more visual, in a graph, which makes it much easier for us to describe the data and understand the data. The first graph or sort of visual aid that we're going to construct is something called a frequency distribution, also known as a frequency table. And the way that I'm going to construct the frequency table is I'm going to come up with some classes for my data. So I'm going to partition the data into classes. And since these are pulses, the classes that make the most sense to me are, pulses that are in the 50s, pulses that are in the 60s, pulses in the 70s, etc. Okay, so I'm going to start by making some classes for the pulse rates. The first class I'm going to use is 50 to 60. There could be pulses in the 30s or 40s. And if that happens, I can just add a class later. I want to be clear that this notation you're seeing right here, the 50 to 60, this means more specifically that the pulse is greater than or equal to 50, but strictly less than 60. Okay, so 60 is not included here, but 50 is. You could also just write the class as 50 to 59. That's fine, and you'll see that a lot also. The second class I'm going to use is 60 to 70. This includes 60 but not 70. Naturally, we have 70 to 80, not including 80. 80 to 90. 90 to 100. I'm going to stop there, but if I have some pulses greater than 100, I can add those later. On the right side of my table, I'm just going to have the frequencies for each class. So what do I mean by that? Well, I'm going to go through my list of pulses here, and what I'm going to do is I'm just going to count how many pulses fall into each of the classes. So for example, here I see a 52. So there's one pulse in here. Here I see a 67. So I'm just going to mark that I had a pulse in there. 74, 71, 68, 67, 83, 74. I didn't want to bore you guys, and so I just completed the table, the counting of the frequencies. But what I found was that there was one pulse in the 50s. There were 6 pulses in the 60s, 11 in the 70s, 5 in the 80s, and 1 in the 90s. So this completes my frequency table. And you can see that when the data are arranged in this way, it's much easier for me to see characteristics of my data set. So for example, I can see that the range of the pulses go from the 60 or 50s to the 90s. Okay. I can also see that most of the data falls into the class for the 70s, from 70 to 80. And I can see that there's a symmetric pattern, right? So we start with just one pulse in the 50s and then increases where we have 6 pulses in the 60s, and we have sort of a climax here of 11 pulses in the 70s, and then it goes back down to 5 pulses in the 80s and then 1 pulse in the 90s. And so we have this symmetric pattern of increase and then decrease. And what else can I see from this data? Well, I can see that there are a total of 24 pulses. So if I add up the numbers here, 1 plus 6 plus 11 plus 5 plus 1, I can see that there were 24 students in this sample. So you can see that this just helps me understand my data better than the list. So there's one more thing I can do that might help me understand and see patterns in my data a little better. And that's what I can do is I can add the relative frequencies here. So what is a relative frequency? So relative frequency just means I'm going to look at the percentage. Instead of looking at the count that you see here, I'm going to look at the percentage. So for example, in the first class, pulse rates in the class 50 to 60, there's 1 pulse in that class. And so I can divide 1 by the total, which is 24. And 1 divided by 24 is equal to 0.04166, and then the 6's continue. So this is equal to 4.166%, which is approximately, so I'm going to round this to 1 decimal place. And since there is a 6 here, that is greater than or equal to 5, and that tells me in order to round, I'm going to add 1 to this decimal place. So that is approximately 4.2%. Okay, so what I'm going to do is, instead of having the frequency, which is 1, I'm going to write the relative frequency, which is 4.2%. Now if I move to 6, okay, if the frequency is 6, then my relative frequency is going to be 6 divided by 24. It's 0.25, which is equal to 25%. And I can continue in this fashion. The relative frequency of the 70 to 80 class is 45.8%. The relative frequency of the next class is 20.8%. The relative frequency of the final class is 4.2%. Okay, and this should add up to roughly 100%. Since I did some rounding, it's probably not going to be exactly 100%. But what we have here is the relative frequency for this set of data. And for most people, it's easier to understand relative frequencies than just frequencies. You know, for example, I know that about 46% of my data values fell into the class 70 to 80. The next thing I want to do is answer a couple questions about the frequency table. So here you see the question, how many students had pulses of at least 80 beats per minute? So just to be really clear, at least 80 beats per minute, this means 80 or more, or if you like algebra notation, this is basically saying x is greater than or equal to 80. So I'm going to go back to the table that we saw previously. And if I look at this table and I ask myself how many students had pulses of 80 or more, so I'm going to be looking at this class and this class, okay? Because this is the class, remember, that contains 80. 80 is not included in this class because of my open bracket here. And I can see that there are 6 students who had pulses of 80 or more. So going back to this question, it says how many? I'm going to say 5 plus 1 is equal to 6 students. Here we have a second question. It's asking us what percent of students had pulses that were less than 70 beats per minute. And we're going to round the answer to 1 decimal place. And so we're going to be actually rounding the final answer, which is going to be a percentage. So first of all, let's make sure we understand what is meant by less than 70. So that's strictly less than 70. So 70 is not included. If you want to write that algebraically, that would be x is strictly less than 70. So again, I'm going to go back to the table, and the relevant classes will be these 2 classes, okay? Because remember that 70 is included in this class, but it is not included in this class. And since we're interested in less than 70, these would be the relevant classes. And we can see there's 1 plus 6. Okay, so there were 7 students who had pulses that were strictly less than 70. So that gives me 7. However, I'm not looking for the number of students, I'm looking for the percent. So I'm going to divide 7 by 24. And that gives me 0.29166 which is equal to 29.166 percent, which is approximately equal to, now I'm going to round to 1 decimal place since I have a 6 here. That means I'm going to add 1 to this guy, and I end up with 29.2%. And that is my final answer here.